Let's work through question 15 from chapter 14. So we were given some x and y values in this question and told that the estimated regression equation for the data is y hat equals 0.20 plus 2.60x. Now there's three different parts that we need to solve. We need to compute SSE, SST, and SSR using equations. We need to find our coefficient of determination and comment on the goodness of fit, and then compute the sample correlation coefficient. So on the screen now are all of our formulas for SSE, SST, and SSR. We're going to solve for SSE first. So we need to figure out the sum of y minus y hat squared. Well, we need to work our way to that point. So we first need to figure out y hat. So our y hat formula was 0.20 plus 2.60x. So if we plug in our x values into our y hat, we will find these values. So if you're working on a calculator and have your x and y values in your first and second lists, in list 3, you can go up to the top of list 3 and plug in 0.20 plus 2.60 times L1, where we have all of our x values. Then that will populate the list for you. Can also notice that we can find these values if we just do 0.20 plus 2.60 times 1. That will get you 2.8. If we plug in 2 into x, that will get you 5.4. So now we can go on to this next list. Y minus y hat. So our y values are in our second list right now. So if we take 3 minus 2.8, that will get you 0.2. 7 minus 5.4, that will get you 1.6. Now our last list that we need is y minus y hat squared. So we are just squaring the last list that we just found. So 0.2 squared is 0.04. 1.6 squared is 2.56. Now SSE is the sum of that list. So if we sum up that list, we will get 12.4. So your SSE in this problem is 12.4. Now SST is the sum of y minus y bar squared. But we don't have y bar quite yet, so we need to solve for y bar. Y bar is just the average of all of your y values. So if you average your 5 y values, you will get 8. So now we can take each individual y value and subtract 8 from it. So 3 minus 8 is negative 5. 7 minus 8 is negative 1. Now we need to sum, or we need to square that last list. So negative 5 squared is 25. Negative 1 squared is 1. And now we can sum this fourth list that we have. And if we sum up that list, we will get 80. So your SST equals 80. Now for SSR. SSR is the sum of y hat minus y bar squared. Well, we found y bar was already 8. And our y hat values, we found those when we were solving for SSE. So we can put all of those into our chart. Now we have y hat minus y bar. So we're taking each of the values in our y hat list and subtracting 8. So 2.8 minus 8 is negative 5.2. 5.4 minus 8 is negative 2.6. So now our last list is squaring y hat minus y bar. So negative 5.2 squared is 27.04. Negative 2.6 squared is 6.76. So your SSR is the sum of that list. So if we sum that up, we will get 67.6. Meaning your SSR equals 67.6. Now there's another way that we could have solved for these values. If we would have just found two of them, we could figure out the unknown by using this equation, where SST equals SSR plus SSE. You can plug in the values that you found in this problem just to make sure that everything works out mathematically. So SST of 80 equals your SSR of 67.6 plus your SSE of 12.4. Now compute the coefficient of determination and comment on the goodness of fit. Well, the coefficient of determination, that's just r squared. And r squared is SSR divided by SST. So we found both of those values already. Your SSR 67.6, SST is 80. We plug those into the r squared formula, and we can find our coefficient of determination is 0.845. Now we need to comment on the goodness of the fit. Well, our regression line is a good fit, but why? So the r squared helps us figure out how much of the change in our y values can be explained by a change in x values. So if your r squared is 0.845, what that means is 84.5% of the change in y can be explained by a change in x. So we want our r squared to be as close to 1 or 100% as possible. Now compute the sample correlation coefficient. That's r. If we take a look on our formula sheet, you'll see the formula is the square root of r squared with the sign of your slope put in front of it. So if we take a look at our y hat formula, we can then find the sign of our slope. So our slope here was the positive 2.60. So that means that the sign of our slope here is positive. So your r is just the square root of 0.845, which equals 0.9192. Now we can take a look at this chart that we have to figure out this sample correlation coefficient. What does this number even mean? Well, our r value is between 0.9 and 1.0, which means we have a very strong correlation. So we can write this out as a very strong positive, since our slope is positive, linear relationship.